Audibility, some problem is there?
No, ma'am.
No, I got a message like it's not audible. That's why. Are you able to hear me? Others?
Yes, ma'am.
Okay. So, so far I have told about the first line agents and second line agents classification. So I'm repeating once again. So when you take a medicinal chemistry chapter, first you need to classify and you have to know the examples. If you are studying about tubercular drugs, you have to know about the pathophysiology, how this disease is caused, what is the basis of this disease, and regarding your drug adverse effects, all these things. In medicinal chemistry aspect, if I am taking a first drug, isonic acid, this is isonicotinic acid hydroside. So let us concentrate on 6 drugs today. So this is a example INH. So bacteria is having a cell wall. So for the cell wall material, the main component is mycolic acid. So one of the component in the cell wall synthesis is mycolic acid. So this isonicotinic acid hydroside. So this is formed from nicotinic acid. So this isonicotinic acid hydroside will enter and they will get converted into isonicotinic acid. INH will get converted into isonicotinic acid and they will mimic mycolic acid and inhibit the cell wall synthesis. So if you take if you are seeing the antitubercular agents, most of the drugs will be acting against the bacterial cell wall. So against the bacterial cell wall, so they will be like against the bacteria, they will be acting like inhibit. They will be acting as a prodrug. Then they will cut down the. They will mimic some of the components of the cell wall, and they will cut down the nutrients needed for the cell wall synthesis. Thereby, the bacteria will not survive. So this way, the bacteria will identify if any unknown chemical X is entering, then the bacteria will be more clever. First time it will be not be the microorganism will not be able to survive. But when the same thing enters second time, then resistance develops. So in case of prolonged, it is a prolonged, the treatment is for a continuous 6 months and all. So in order to get cured with, it takes a dose, it takes a long term. So that's why the bacteria will be more clever and it will prevent the entry of these or it will be resistant towards these type of chemicals. So that's why the combination also in case of tubercular diseases or pulmonary, the treatment of pulmonary tuberculosis, we will be going for the combination, multi-regimen, multi-dose. That way we are preventing the multi-drug resistance. So when you are seeing the first drug is INH, INH is isonicotinic acid hydroside. So how to synthesize? So we will see synthesize for last 10 minutes. First I will tell you about this drug. You have to draw 6-membered ring containing 1 nitrogen. Then here you are having a ketone CO. Hydrazine means NH2 NH2. So here we are substituting NH2. So there is a ketonic group or a carbonyl group connected with NH2. So this way the synthesis is, you are seeing nicotinic acid we would have studied in your biochemistry. So this is alkyl pyridine. This is an alkyl pyridine, methyl pyridine. This alkyl pyridine on oxidation, it will be getting converted into methyl group. Alkyl group get oxidized into carboxylic acid. So the carboxylic acid formed will be getting converted into an ester by the reaction of alcohol. The carboxylic acid gets converted into an ester. The ester will go with the addition reaction. So carbonyl group will go. If you see in your first year, you would have studied, I think in your first year, you would have studied the functional properties of the aldehydes and ketones or carbonyl compounds. The ketones and aldehydes will go for addition reaction with hydrazines and hydrazine derivatives. So hydrazine, it will form a derivative. That's why it is isomer of nicotinic acid. So pyridine, nitrogen is 1. So if we are counting like this, 1, 2, 3, 4. So in the fourth position, you are having a carboxylic acid group. I hope you are listening. So to make it easy, I am telling you. Then if you understand some simple structure, it will be easy to remember the complex structure too. So then the carboxylic acid is converted into an ester, hydrogen is replaced and you have a ethyl linkage. And then the carbonyl group, the OC2H5, it is removed as ethanol and the carbonyl group will go for the addition reaction with hydrazine in order to form the particular isonicotinic acid hydrazide. So INH or isoniazid, both are same. So the mechanism of action, already I have told, this mimic the mycolic acid, which is essential in the synthesis of bacterial cell wall, thereby it inhibits. So it acts as both, in the higher concentration it is bactericidal and in the lower concentration it is bacteriostatic. So static means prevents, cidal means kills. So it both it prevents and as well as it kills the bacteria. I hope this is clear. So that's the first simple drug. Then we have to study like why we are concentrating in pyridine carboxylic acid. So the mycolic acid will have the similar structure. That's why this particular fragment is needed. So the activity is compared. When the activity is compared with the biological relationship, that is called as structure activity relationship. So for every drug, we need to remember the basic fragments which are essential for producing the biological activity. So when you are measuring that amount, then it is called as quantitative structure activity relationship. So in your medicinal chemistry aspect, this is isonicotinic acid, isomer of nicotinic acid. So isonicotinic acid is isomer of nicotinic acid. This is pyridine 4 carboxylic acid. This is otherwise called as pyridine 4 carboxylic acid. Then it is getting converted into ester and followed by addition reaction. So here we are concentrating on the functional group reaction of ketones, the functional group addition reaction of ketone in order to get the product. Some more we need to remember. So we have to make some clues and practice it. So coming to the next drug, pyrazinamide. So pyrazinamide is 6-membered ring. Pyrazine, 6-membered ring containing nitrogen at 1,4 position. So we are having a amide group. So that's why it is pyrazine carboxylamide. So it is pyrazine amide. So we are taking orthophenylene diamine. This reacts with glyoxal. Then there will be a ring closure. So there will be a ring closure formed here. CHO, CHO. This is glyoxal. Glyoxal is formed from your dihydric alcohol. Dihydric alcohol on oxidation will give glyoxal. Then the glyoxal reacts with orthophenylene diamine.